Hello. This video is going to be to review numbers 13 through 16 from worksheet 7-8, and also I have 3 problems from the chapter review that I wanted to talk about. So on worksheet 7-8, number 13 through 16, you're given a number line, and it says in each figure a point between A and B on the number line is chosen at random. What's the probability that the point is between C and D? So I wrote out, here's number 13, this top one right here. So we go from -2 all the way up to 4 on this number line. And we need to find out how many units are between A and B. So here's A. I'll use a different color for this. Okay. Here's A, and it goes all the way to B. That's what we're concerned with. So, let's see, how many numbers could be chosen between A and B? It depends on how many units are between the two. So we have 1 unit, 2, 3, 4, 5. There are 5 units from A to B. So there are 5 possible outcomes if you chose a random number in between them. Okay? Now, it says, what's the probability that the point is chosen between C and D? Okay, how many possibilities are there that it's between C and D? Well, how many units are in between C and D? I'll use another color. The number of units between C and D is right here, just 1. So, let's put 1. Okay, so the probability is 1/5. And we need to transfer that into a percentage. You might know just off the top of your head what 1/5 as a percentage is, and if you don't, you can do this little equation really quick. Percents are how many out of 100. So 1/5 equals how many out of 100. Make this x. You can cross multiply. So 1 times 100 is 100 equals 5 times x is 5x. So you take both divided by 5 to get x by itself. Sorry. 100 divided by 5 is 20. 20 equals x. So the answer is 20%. Okay? 1 out of 5. So let's do another one. Number 13 is very similar. Or sorry, 14. Very similar. We have just have a different number line. So we need to find how many units are between point A and point B. So I'm going to count. Well, here's A and here's B. So we've got 1, 2, 3, 4, 5, 6. 6 units between A and B. So that's going to be on the bottom. Now, what's the probability that the point chosen is between C and D? Well, we need to know how many units are in between C and D now. We've got 1, 2, 3. So the probability is 3/6, which equals 1/2. 1/2 equals how many out of 100? You can probably just do that in your head. 1/2 of 100 is 50. 1/2 equals 50/100. So the percent chance is 50%. That's the answer. So now we're going to do number 15, which looks like this. So we need to find the number of units between A and B. So we have A here, so there's 1, 2, 3, 4, 5. So 5 will be on the bottom. And now we need to find the number of units between C and D. So we have C here and D here, so there's 1, 2. 2/5 is the probability. We need to turn that into a percent. So I'm going to take 2/5 equals x/100. Cross multiply. 2 times 100 is 200. 5 times x is 5x. 200 divided by 5 and 5x divided by 5 leaves x alone on one side and 40 on this side. So probability is 40%. Okay. And we have one more that we're going to do. And it is units between A and B. So 1, 2, 3, 4, 5, 6. So there are 6 total possibilities. We want to know how many of those possibilities would fall between C and D. We've got 1, 2 units. 2 over 6. Make that x over 100. That's going to be cross multiply. So 200 equals 6x. Now, if you put that into your calculator, you will find, you will find that x equals 33 1/3%, or 33.3333333333. So that's 1/3. 2 over 6, 1/3. 1/3 chance. Or 33.33333%, or 33 and 1/3. Sorry, 33 and 1/3 is what I meant. Not 1/2. 33 and 1/3%. Any of those answers, either of these two. Well, you wouldn't need to go all the way out there, but you could say 33.33% would be good too. And so that's how to do number 13 through 16 on worksheet 7-8. Next, I'm going to talk about a little bit about the chapter review. Okay, we are on page 411, and we're going to talk about 3 problems from the chapter review that reviews 7-6, 7-7, and 7-8. We will be looking at number 25, 27, and 28. Those 3 problems are from the same section of the review, and we're talking about how to find the length of an arc. Okay? So first I want to look at a couple of examples that are a little more basic to help you figure out why this formula that they give you works. Okay? So if we have a circle, let's look at this one right here. Now let's say we figure out the entire perimeter of the circle is, let's say that is 12 inches. Is the perimeter of the entire circle. Okay. Now, if I wanted to know what's the length of this part of the circle, this arc right here in black, okay, I would take, we know that the entire circle is 360 degrees around, right? This, the angle of this, is just a straight line, so it's 180 degrees. 180 divided by 360 reduced equals 1/2, 1 over 2. So to figure out how many inches this segment is, which is exactly 1/2 of the entire circle, we would take 12 inches times 1/2, which is just like taking it divided by 2, and we would get 6 inches. Without doing all of that, I'm sure you knew that this was going to be 6 inches because you knew it was just half of the entire thing, okay? So we did that. Let's look and make sure that our formula makes sense then. We have the arc, whatever it is, AB, is the measure of the angle, the inner angle, divided by 360. In this case, the inner angle was 180 degrees. We divided it by 360, times the entire area, perimeter, which is 2 pi r. Let's try that again. Let's apply this one to this here. So let's say this is arc AB. AB. Okay? So the length of AB is the measure of AB. Well, we know this is exactly 1/4 of the 360 degree circle. We also know that that means it has to be perpendicular. So this is a 90 degree angle. So the measure of AB is 90. The measure of the entire circle is 360. This fraction is going to give us what percent of the circle this section is. Okay, and then we're going to take that times 2 pi r. So let's say this is 2 centimeters. So 2 times pi times 2 is 4 pi. Okay, 90 over 360 reduced, I'm just going to give it to you, is 1/4. which you probably could have guessed because this is 1/4. So 1/4 times 4 pi. Oh, this is going to be funny. It's going to actually result in just pi, I think. So if we take 1/4 times 4 pi, we get 4 pi over 4, which actually just equals pi. So that's how the formula works. Neither of those were any of the problems they actually had to do. That was just an explanation of why the formula works. So let's look at number 25. This is the diagram that we have. So the measure of arc length AB, we'll say this is A, this is B, whatever arc length they're giving you, equals the measure of AB, which is 110 degrees, divided by 360, times 2 pi times 4. Okay, so we can reduce that down. 2 pi times 4 is the same as 8 pi. So let's just do that. Make it over 1 to make it a little easier. So let's see, we need 110 times 8. 110 times 8 is 880 over 360. Let's take both divided by 2. I'll just kind of work our way down and see what happens. So 440 divided by 180, 220. Actually, we can just drop the zeros off there. 18 divided by 44. Let's divide that by 2. 22 divided by 9. I don't think they have anything else in common. So 22 pi over 9. Let's see if that's the right answer. That is right. You can write 22 pi over 9, or you can put 22 over 9 pi. Pi is not on the bottom, it's just next to it. Or you can put it on top. Alright, so that's the answer. 22 over 9 times pi. Oh, I thought all of the problems that I was going to do were about the same thing, but they're not. So here's number 27. I think I've done a video about this type of problem before. Basically, we need to find the area of the shaded region. So what we need to do is find the area of the entire circle, use that to figure out the area of this pi piece, and subtract from that the area of this triangle, and we will be left with the shaded region. So the area of the entire circle is pi r squared. The radius is 8 meters, so that means 8 squared is 64. So 64 pi is the area of the circle. Now we can look at this circle and know that it's in a 90-degree angle. So we can figure out what percent of this circle, if you didn't just see it and know, you can find the percent of the circle that we need is 90 over 360. 360 is the total degrees around the circle, and this is 90 degrees that we're actually looking at, which reduces down to 1 over 4. So what we need is 1/4 of 64. So what we can do is take 64 pi over 1 times 1/4, which ends up just being 64 pi divided by 4. And that would be 64 pi divided by 4. We can just do, we don't have to reduce pi down to anything. We can just do 64 divided by 4, which is 16. So 16 pi is the area of this section right here, this pi piece right there. So we don't really need this anymore. We don't want this entire area, we just want this little section here. So we need to subtract from 64 pi the area of this triangle. Luckily, this is a very easy triangle to figure out. We know this radius is 8 meters, then we know that this is also 8 meters. So the area of a triangle is height, base times height, divided by 2. Okay, so base is 8 meters, height is 8 meters, so 8 times 8 divided by 2 is going to be our answer. 8 times 8 is 64. Divided by 2 is 32. Sorry, divided by 2